Okay, right. So thank you for coming. Today we'll be talking about the Mikrotik Switch features. Okay, my name is Ahmad Mardiansyah and I'm from GLC Networks Indonesia. Okay, so here are the agendas. Review prerequisite knowledge. So make sure that you know what's going on. Just refreshment about what you have done. If you miss something, and then we can just repeat that. Okay. Repeat what we already know, and then if something is missing, so perhaps we can catch up here. And after that, we talk about Mikrotik switch and then switch features. Okay, simple agenda. Okay, introduction. We are GLC Networks. We are based in Bandung. We do training and IT consulting. We do Mikrotik, Ubiquiti, Linux, and then programming. We develop our own software for radius, for billing, and then we do general regular events like our webinar today. And then my name is Achmad Mardiansyah. I'm lots of users, Linux user, Mikrotik user, other brand of Mikrotik, other brand of networking. I do teaching, networking, and then we do also consultation. I have LinkedIn here, guys. If you have LinkedIn here, okay, please, please connect with, with me. Okay. So this is our past experience. Most of the time, we do a network support, billing integration, IoT integration, and then network support. Okay, in Asia, in Europe, in Africa. The latest was in Congo and Papua New Guinea. Oh, I haven't updated the slides. Okay, next time when I upload. So this is our webinar. So please, guys, if you want to be a presenter, okay, please tell us. Okay, yeah. So we already have a collaboration webinar with our external GLC networks. Okay, so we discuss many topics, but most likely the topics are related to networking, system administration, and then programming. All right, so yeah, thank you very much for introduce yourself. I can see here there are people from Sulawesi. Okay, thank you. From Wayan, yeah, okay, thank you, Wayan. I have South Borneo, Kalimantan Selatan, yeah. Okay, Sharuni, thank you. Wutipong, okay, Wutipong, I know this guy. Thank you, and then nice to meet you again. Okay, and then we have Farida here. Okay, I think you are the one from France, yeah. I bet it must be very cold over there. It's in December. Yeah, must be very, very freezing over there. Okay, anyone else? Please introduce yourself here so that we know where you're from. All right, so, oh, I haven't updated this slide. Okay, prerequisite. So we assume you already know, of course, networking, so that you can understand this the material well. Okay, let's do review. So we know that when we talk about networking, we cannot get rid of these things. Okay, OC layers. Okay, what's the abbreviations? Please do not throw sausage pizza away. Yeah. So 7 OC layers. So the way we communicate is by having an encapsulation from one layer to the other layer. Okay, so as simple as that. And then every layer has its own unit. It's called protocol data unit or PDU. And then each layer has its own PDU. Started from the data. Okay, so we compare between OC layers and then TCP/IP. And then here's the data. And then on layer 4, we have a segment or datagram. Okay, on layer 3, the PDU is called packets, and then on layer 2, it's called frame. And what about layer 1? Layer 1 is just bits 0 and 1s in the physical representation, either with the electromagnetic like radio wave, or with electrical signal if it is Ethernet cables like 1 and 0 with the voltage, or with the lights like when you are using fiber optics. Okay, here's some example of header, layer 4 header, layer 3 headers, layer 2 header. Okay, and then this is another layer 2 header with different technologies for wireless. Okay, and then as you can see, there are lots of encapsulation process start from layer 7 to layer to the lower layer. Okay, so this is what you send, and then eventually what you send is here. Okay, so this is what you type. Okay, you type only hello, but the actual data that the computer sends is that long. Okay. So when we talk about connecting network devices, so we know that there are end devices, intermediary devices, and then the media, right? So end devices connect to the other devices, using the media, and then intermediary devices means the signal not ends there. The intermediary devices will forward the signal and then send it to the others. Okay, that's the big difference between end device and an intermediary device. Okay, and then we set up our physical topology. This one connects to that one physically. Okay, so with the physical topology, we know that, okay, this port connect to that port, and so on and so forth. We know that also with the physical topology, we know that we have a difference between layer 2 and layer 3. Okay, so here is layer 2. Okay, the red one over here. Okay, and then the layer 2 are connected through a layer 3 device here. Okay, so router works on layer 3, but others work on layer 2, and then they're connecting to each other. Okay, so we have a physical topology, but when we do design, we only focusing on layer 3 for network planning. Okay, so here we don't use a segment anymore, how many switches. Okay, so what our focus here is for routing and then addressing. Okay, so this segment is using this IP address, segment of IP address, that this area is using this IP address. Okay, so that's how it works. Okay, yeah, so we do routings, and then that's how it works. So today, because we are talking about switch, we are focusing on layer 2 technology, which is Ethernet. Okay, because if you use token ring, we don't use that kind of switch. Okay, so we use switch if you use Ethernet. So that's why we need to redo a refreshment about how Ethernet works. Okay, so this is Ethernet specification defined by IEEE 802.3. And then the media can be coaxial cable, twisted pair, fiber optic. Devices required, we have a bridge or a switch, and then or hub. Okay, so here's the devices, and then everyone likes it because Ethernet is affordable, easy to install, and then easy maintenance. I remember when I learned networking for the first time, we use Ethernet that is based on coaxial cable. It was very, very, very fragile network. So if somebody trip on the cables, and then the whole network is down. So we are using a bus topology. Okay, so if you use Ethernet, and then of course you need to know how Ethernet works, like CSMACD. So when one sends, and then if you use a hub here, okay, the signal will be sent to other hosts. Yeah, so it will be broadcast every time the central device receives a signal. So By doing so, we will have a collision domain and then broadcast domain. Okay, so these are the different things. Collision domains is where the collision happens. Broadcast domain is where the broadcast happens. Those are two different things. And then so we also know that CSMA CD is different compared to CSMA CA. CSMA CD CA means collision avoidance. Yes. So this algorithm is used on Wi-Fi. Yeah, but with Ethernet we are using CSMA CD. And also when we use Ethernet, we cannot get rid of these things that is called ARP. Okay, so ARP is a mapping between IPv4 and IP and layer 2 address, which is the MAC address. And then for the first time, it sends, for example, PC number 1 wants to connect to PC number 5, and then PC number 1 do not know the MAC address of PC number 5, so that's why it sends the broadcast ARP request like this to everybody, and then the number 5, PC number 5 will reply with the unicast traffic. Okay, so the first ARP always requires broadcast. Okay, and then how the broadcast frame looks like. Okay, so this is how the broadcast looks like. Yeah, this is ARP, and then the type is ARP. So the destination will be FFFFF. Okay. So this if the switch receive this one, and then it will be broadcast to any other ports. Okay, so at least by this point you need to know about yeah, so as you can see, yeah, this is the broadcast address, right? Yeah, so we need to know the concept of how ARP works, and then how ARP can be part of communication in layer 2. And then Ethernet is evolved. Okay, evolution start from 1980s up to now, and then it's keep evolving. Okay, we have previously when I learned networking, we only have a 10 Mbps speed, and after that we have 100 Mbps. That is called fast Ethernet. It's called fast Ethernet, but actually it's just a marketing name for 100 Mbps. And after that we have 1 gig, and now 10 gig is more common now. Okay, and then in the future we have 20 gig, 25 gig, 40 gig, 100 gig, 200 gig, and so on and so forth. Okay, in some areas they already implemented the 100 gig. Yes, it's very expensive, not in our daily place, but yes, it already happens. Okay, so we also know that we already know that how the switch, how the Ethernet works, so that we need to be aware that the Ethernet issue that comes along with the Ethernet. For example, the collision domain, for example here, yeah. So when a frame coming to a hub, and then it will be broadcast to everybody, and then at the same time, if somebody is sent, we will have a collision. Okay, so if we have a collision, and then we have to wait for a number of time, and then to resend the frame back. Okay, so in order to eliminate the collision domain, we replace the hub into switch. Okay, because switch has, oh, we have an animation here actually, but yeah, but it's not working because this is the PDF. Yeah, but never mind. Okay, so with the switch, we can split the collision domain into per port. Okay, so this is very, very massive improvement. Okay, and then now it's very hard to find a hub. A switch is very, very cheap now. Okay. Next is about broadcast. Okay, so this is the area where the broadcast happens. So for this one, we can split the broadcast domain with the layer 3. So we can split them with the router so that we have a broadcast domain over here, over here, over here, and over here. Okay, so we have 1, 2, 3, 4 broadcast domain. Okay, so that was the broadcast. Next is issue with loop. Okay, so this is very, very dangerous. Yeah, and then some of my clients are experiencing this in their network, especially if their network is quite big. Okay, so this is very, very dangerous. And then, yeah, if it happens, and then it's very, very hard to troubleshoot because you have to unplug one of the cables. Okay, so the way it happens is when somebody send a broadcast frame. Remember broadcast frame, right? The FFFF. So that broadcast frame receive only one frame over here, but will be duplicated. So the the switch will do a duplication of that frame. Okay, one sends to here, one sends to there, this one sends to here, this one sends to back there, this one also sent to there, and the frame keeps moving and moving in the network until one of the switch here is down. Okay, so if it is down and then, oh, okay, now it's better. That's just because the switch is hanged. Okay, so for that we don't have to use a traditional switch. It's not recommended to use traditional switch. Yes, it's cheap, but better not to use it. Better use a switch that has STP protocol. There will be a topic for STP, yeah, yeah, but that's for another webinar. Okay, so that's the loop. And then another interesting things for layer 2 technologies. We already know the issue. And then one nice thing about the layer 2 technology is the Vlan. Okay, Vlan is very, very good. Okay, we are using it every day. It's very, very save us in terms of effectiveness and then efficiency. We can save money. Okay, so as you can see here, if we don't use VLAN, we have a requirement for segmenting our networks. Okay, we have two sites, sites A and sites B over here, right? Okay, site A and site B. Guys, if you have questions, and then please type something in the group chat. Okay, so if you want to split our network, and then we can do that using VLAN. So we just only buy one switch, and then inside the switch we can do partitioning based on the ports. And then between switch we can set up a trunk so that they can bring our traffic from particular area with a particular tag. Okay, so this is how it looks like. So VLAN, and then we have a segmentation is extended using trunk. So we have an access port. Okay, so access port that usually connects to the end device, this port over here. And then we have a trunk port that connects to the other switch. Okay, it's borrowed from the telco terms, the trunk. Trunk is a link that connects to telco exchange. So we have access, we have a trunk, and actually we have a hybrid. Okay, yeah, this one allows a tag and non-tag frame. Okay, so this is the trick for VLAN. Okay, so we are using tag and non-tag. So that way we can achieve our goals here for segmenting our network, okay, with a single switch. Okay, so I have one question here from Nino. Advantage of Vlan. Okay, we already discussed that a moment ago. Yeah, so this is the advantage of Vlan. So we have flexibility for partitioning our network. Okay. So this is what happened in the VLANs. what is it? The protocol is called the 802.1q. Okay, .1q. It's called VLAN. Okay, so if you Google it and then, yeah, that's the standard for VLAN. How VLAN works will be put there. Okay, so yeah, the thing is, this is the tag. Okay, and then the tag will be put on a trunk port over here. And then the tag will be removed on access port. So please understand the concept of VLAN, because this is very important of understanding how the switch work. Okay, so this is, for example, yeah, so as you can see, this is non-tag port. So we have a switch here, and then on the switch we have Ether 2, Ether 3, Ether 4, Ether 5 ports. Okay, that connects to end devices. Okay, so this is end devices. Okay, and then end devices, as I said, can be this is a access port. Okay, and this is a tag port. Okay, access port mean no tag, and then this one is tag port, and this one has hybrid. Okay, so it can connect directly from here to there. It can connect from non-tag with tag. Okay, and then it can connect from tag with tag. Okay, so we have here, as you can see, we have VLAN 20 over here, and then over here we have another VLAN 20 connects to that. And here we have a VLAN 20 over here with tag, but that one we with VLAN 10 has a non-tag over here. So sorry, so this is non. So I repeat, I updated my explanation. So these two ports are non-tag. This one is tag. Okay. But over here, this is over here. This is hybrid port. Okay. So because it allows tag and without tag, both of them are allowed. Okay. So now let's talk about Mikrotik switches. Okay. So actually Mikrotik produced switches since many years ago in late 2000s, I think. Okay, but that one is only around 5 ports. Okay, and then they also introduced. We already know that Mikrotik has router OS, right? But for this one, they introduced the switch OS SWOS. Okay, and then this was only for Mikrotik hardware. Okay, but you know, 5 ports is not enough. In our office, we have more than 5 ports, right? And then it's not economical if we buy multiple 5-port switches. Yeah, it's ridiculously expensive, and then it's hard to manage. So yeah, Mikrotik, I think not 2014, maybe later. I didn't remember the year exactly. Maybe 2015 or 16. Yeah. So Mikrotik produced large port switches since this year. Okay, I need to Google the year, but perhaps you can inform me where the Mikrotik starts producing the switch with more ports. Okay, but yeah, this is my opinion. The switch features and then configuration is currently depends on the switch chip that they are using. Okay, so it's less comfortable. So if when you buy a Mikrotik switch, you need to know, oh, okay, so this switch is using this chipset, this switch is using that chipset. Okay, and then the chipset will determine how you configure the switch. Okay. So currently, if I can say, so the way Mikrotik configure the switch can be grouped into two of a family. So if you buy Mikrotik with 1XX or 2XX, like this one over here, okay. Yeah, and then the way they configured is similar. But I would prefer this one, yeah, 3XX. Yeah, it's much a little bit expensive regarding the price, but the configuration wise, it's okay. Okay, so I have a connection with the 3XX switch here. Perhaps I can share how we connect to the switch. Okay, it's not in my place, but yeah, we can try to connect. Yeah, so yeah, again, when you buy a Mikrotik switch, make sure is it which family is it? Okay, because the family product family will determine how you configure the switch. Well, it's not comfortable. Yeah, I understand. But yeah, that's how Mikrotik produce their switch. Okay, so it's not like one fit for all. No. You need to check about the switch configuration. Regarding Mikrotik switch itself, we have two categories. We have a CRS or CSS. Yeah, so CRS means cloud router switch. So as you can see, we have a word router here. It means that it will use router OS. Okay, so it means that if you use router OS, then we can do layer 3 switch. Actually, it's routing. Okay, layer 3. There's no switch on layer 3, right? Switch is layer 2. So that's why we call it layer 3 switch. So that means the switch that can turn into a router. Yeah, as simple as that. Okay, so please understand the term. Okay, please do not. I already discussed this with the Mikrotik user meeting in the Mikrotik user meeting in Indonesia last year. Yeah, so where I talk about please understand. Do not be fooled by the sales guy. Okay, understand what you need. Understand VLAN. Okay. So because again back to here, because we use router OS, and then we can access we can access the switch is by using lots of options here. We can use Winbox, web-based, SSH, Telnet, FTP. But Cloud Smart Switch is different, so it's using Switch OS, so you cannot access, you cannot use Winbox to get in. It can only provide layer 2 functions, okay? Just VLAN, or you cannot do set up PPPoE or ping or that kind of stuff, okay? That kind of layer 3 stuff, okay? So only focus on layer 2, okay? And then we have a web interface only. Yeah, so that was the CSS. Well, it's cheaper, yeah. But yeah, the functionality less. Okay, so hope you understand the difference between CRS and then CSS. Okay, so let's talk about the switch more technical. So as you can see, by default, Mikrotik is a router, and yeah, in this explanation, this presentation, I will talk about the CRS. Okay, the switch that has a CRS, that has CRS type. Sorry. So that switch can be turned into a router. Yeah. So basically, it's a switch. Yeah, but that can turn into a router. But why? So it's cheaper. Yes, it's cheaper. But why don't we just use them as a router? Well, no, it's not. Why? Because this CRS is designed for layer 2. You can use them as a layer 3. Yes, you can. But you must not. Okay, you don't have to. Okay, you can doesn't mean you have to. Okay. Okay, remember what I said. It can, but doesn't mean you have to. Okay, you can turn that switch into a router, but you don't have to do that. Why? Because the routing performance for a CRS is very bad. Okay, I have a client with the CRS, and then they connect the CRS into an upstream only 10 Mbps, and then the CPU goes up to 40%. Only 10 Mbps, man. with the CRS. So the CPU is not that powerful. Okay, so actually Mikrotik is a router. So as you can see, this is Ether 2, this is Ether 3, Ether 2 connect to this segment, Ether 3 connect to this segment. Okay, so when we combine them, okay, so when we combine, so all of them will have a same network address. Okay, so the way we do that is we create a bridge over here. Okay, and then after that we add the ports. Okay, as simple as that. So same thing in the when you configure the the bridge in a normal Mikrotik router, so that's what you do. So same thing with the CRS. Okay. Okay. So actually every port here has its own MAC address. Okay. But if you put all of them into one single bridge, and then all the MAC address on every a port will be eliminated, and then will be replaced by this MAC address over here. If you want to make the MAC address to be customized and then not change after reboot, and then you can put the MAC address over there. So MAC address is sorry, MAC address is important as big yeah, as a place for identify your bridge. Okay, but actually we don't need the MAC address because it's just layer 2. Okay, but if you have things like a bridge or STP, or you want to put an IP address so that you can connect to your switch, and then you need to have a MAC address on the bridge. Okay, so yeah, that's how we turn the router into the bridge. And then here's the VLAN. Okay, so VLAN, we can add VLANs on a particular interface. So as you can see here, we have Ether 5, and then on Ether 5 we have 2 VLANs on that. So Ether 5 is the physical interface, but the VLAN 10 and VLAN 20 is the virtual interface. So Mikrotik will consider the VLAN as an interface, and then that interface is logical interface. You cannot see the interface, but we can treat the logical interface like a separate layer 2 or 3. So as you can see, when you set up, so we have a MAC address on Ether 5, right? So we have MAC address. So what MAC address do we use when we put a VLAN on that? So we will use MAC address on Ether 5. Okay, so remember this is very important, especially when you implement Mikrotik switch on multiple vendor switches. we have a very yeah, we have a issue in our clients regarding the multiple vendors of VLAN. Okay, and sometimes it happens loop happens many times. Yeah, so this is so please understand how the VLAN works and how Ethernet works. The MAC address, the ARP, and then the broadcast frame, and so on and so forth. Okay, so your concept will help you to troubleshoot problems in the network. Okay, so if we use CRS, and then especially CRS version 3XX, so we can do VLAN filtering. So instead of putting a VLAN logical VLANs on that particular interface, like a Ether 5, like what I put previously. So actually we can do a VLAN filtering. So as you can see, like, so this concept is similar to like when you use Cisco or you are using Ubiquiti. So you can do VLAN filtering. You're saying that, okay, this VLAN, this port over here, so this is the port, right? Okay. and then it's a normal native VLAN is there, and then here's the frame types. Okay, admit all or not. Okay, so this will determine, as I said previously, we have three, right? We have an access port, we have trunk port, we have hybrid port. So this one will be determined over here, frame types. Okay, so and then we set up the filtering. So we set up a bridge local, and then here's the VLAN ID. So we said that, okay, for the tag VLAN is this one, for untag is this port. Okay, so this is the list of the port where we say that, okay, on this port is tag for a particular VLAN, for example VLAN 10. Okay, so we have VLAN 10, and then on VLAN 10 this is the tag port, this is the untag port. Okay, so this is how we do VLAN filtering for in Mikrotik. And then this is very useful in to avoid the looping on the network. Next is about the VLAN hardware offload. So this is an example. Well, this is quite messy over here, so sorry for that. So as you can see, okay, where do we start here? Okay, I will use different color, perhaps orange. Yeah, orange. So as you can see, we have hub AC. So we have hub AC over here. Maybe not this one. Yellow. Yeah, we have a hub AC over here. Okay, and then we have, so before we buy a switch, so better if you see the technical spec or the technical spec of particular a switch. Okay, so there you can see which chipset they are using. Okay, and then you can see them here, over here. Okay, and then you as you can see, this is the chipset for processor. Okay, and then here's the CPU. CPU is here. Okay, MIPS BE, and then hub AC, you can see it over here. Okay, and then we also see this is hub AC, and then here's the architecture. Okay, so we know this is the chipset that they are using. You can see it also from the switch menu on this one. Okay, and then this one has two wireless, right? So as you can see, we have a two wireless over here, and then the first wireless is using this one, and then you can see it from this one. This is the first wireless, and then here's the chipset that is used by the first wireless, and then here's the second wireless. Okay, and then here's the chipset that is used by the second wireless over here. Okay, so your bridge is this one. As you can see, this is your bridge. Oh, sorry, not that one. So that's the Ethernet. Okay, so here's the Ethernet over here. So you have a 5 Ethernet and then one SFP. Okay, and then you have a bridge over here, and then the bridge, you put all of them into one bridge, which is bridge local. Okay, so as you can see, some of them has AH, means hardware offload. As you can see, we have a switch chip over here that handle the 1, 2, 3, 4, 5 Ethernet. Okay, so that means if you transfer from port number 2 to port number 3, it will be faster, and then the switch chip will do support for that traffic. Okay, because it's handled by the hardware, so nothing to do with the CPU. But if you send traffic from Ether 2 to SFP1, okay, and then the CPU will go higher. Why? Because it's not handled by the switch chip. Okay. Yeah, so this diagram is very important, okay, to understand the weird behavior that you might find when you implement the bridge. If you send Ether 4 into wireless LAN 1, and then you will use CPU as well, okay. So because yeah, the wireless is not handled by the switch chip. Okay, so please do understand the hardware offload. In one side, it can reduce the CPU usage, but yeah, you need to be aware that not all ports are handled by a switch chip. Okay, so that's the hardware offload. Next is loop protect. Yeah, so loop protect is a feature, okay, for disabling port if they detect a loop on the network. So here's the idea, okay, so a frame, so if the frame coming from here, send to there, the same frame should not come back to here, okay. Logic, right? Yes, anybody get the point? Yeah, so if a frame sending from here, the frame should not come back to that originating port. So that's the idea. If the same frame come back, because it's from this MAC address, right? MAC address number 1. So if the MAC address number 1 as the source address sent to the network and then come back, and then we know that, oh, okay, there is a loop over here. That's how we detect a loop. Okay. So yeah, like this one. Yeah. So if the port is, if the switch is good, and then yeah, there is a mechanism to avoid loop. Okay, so loop protect is one way to avoid that. Next is about the next is but it's not recommended. Yeah, there is a feature for loop protect, yes, but it's not recommended. Mikrotik prefer to use STP or RSTP for that. Okay, so this is how it looks like. Okay, so actually this is not a switch feature. So this is more on the bridge. Okay, so the switch features that are mentioned here is the features that is related with the particular hardware, chip hardware. Okay, so STP and RSTP is not part of it. But okay, we will discuss about the STP at the moment. Okay, so just discuss about that. So STP and RSTP is used so that we know that in these three a switch has a loop, right? So as you can see, if all switches implements STP or RSTP, this link will be off automatically with the STP protocol. Okay, so the way they do is they are communicating to each other. Okay, by sending BPDU, bridge protocol data unit, send to here, send to there. Okay, they are sending to each other. Okay, saying that, oh, okay, I'm a switch. Okay, I'm a switch too. Yes. And then they will do election, okay, to define the root. Okay, so let's say this one is root, and then so it's like a tree, right? So this is tree. So with tree start from root, right? And then we have a branches over here. Okay, this is our tree. Yeah. So how do we detect a loop? So this is root. And then we have a branch over here, branch over there. If there is a connection between branch, and then automatically we know that, oh, okay, we have loop over here. And that's how the STP works. Okay, if we detect that there is a loop, and then the link will turn off automatically. Okay, this is also um, uh, 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 what is it? uh, Important things to know that uh, when you create a bridge, for example, this bridge, okay, and then we can select the protocol, either STP or RSTP, so all of them are are compatible to each other, and then here is the priority. Okay, so Mikrotik put the priority in the hex decimal, but in other vendors we use decimal. Okay, so 84096 is 1000 in hex. Please understand. Okay, and then in order to have a capability, compatibility with other switch, this is this is very important. So we need to put here a number as the step of 4096. Okay, so start from 0, 4096, 8192, 12, 28, 288, and so on and so forth. Okay, so in Mikrotik we have 1000 hex, 2000 hex, 3000 hex, and so on and so forth. So 1000 hex, like this one over here. Yeah. So 1000 hex is similar to 4096. Yeah. 2000 hex is 8192, and so on and so forth. So what about 8000 here? 8000 means 4096 multiplied by 8 equal to 32678. Yeah. Yeah, how do I know? Because I already calculated. Yeah, please do remember, okay? So please use this number. Okay, do not just randomly put number over here. So if they are Mikrotik, between Mikrotik, that's fine. But if you are multi-vendor things, and then yeah, that's the thing you need to consider. Okay, so next is in other vendor. Uh, in other vendors, you might see a mirror port, like in the Cisco or I don't know, in other vendors. Okay, so here, because you cannot sniff anymore, you cannot sniff because all of them already put into a bridge, already handled by because all traffic is already handled by this switch chip. Okay, and then if you do sniffing like a torch, it means that you are using CPU. Okay, CPU. This is CPU. Okay, this is sniff. Okay, sniff. So sniff using CPU, and then your port is handled by switch chip. So that's why you cannot do sniffing. Okay, so that's why. How do I do for sniffing? So that's why you can do mirror port like this one. Okay, so you can say here's the actually this is a new switch rule: action copy to CPU or redirect to CPU. Okay, which port here? Okay, so we have like this is like a firewall. We have a match, we have action. Okay. Well, so I think that's all, guys. Yeah, I tried to log into my own switch over here. Yeah, but it takes time to get in. Oh, okay, so we are in here. Okay, so this is a switch. Yeah, it takes time, man. Look, when I click, it doesn't display anything. Yeah, so as you can see, my switch is using three series, okay, 3XX, okay, and then it's using ARM. See, I'm using version 7. Okay. Yeah, so as you can see, yeah, so these are the features. Oh, I don't know what's going on here. It's very hard to display the content. Yeah, it should display over here. Yeah, so as you can see, this we have a switch chip over here. Okay, and then this is the chipset that we can use to identify which model, which switch model we are using. Yeah, but I'm sorry, it doesn't display here. Okay, let me try again. Any questions so far? Hello? Yeah, you can
No.
type in a group chat. You want to you want to use your mic, okay? Okay, I can see here it's already display. Oh yeah. As you can see, yeah. So as you can see, this is how we configured our switch, and then as you can see, all of them, we have a switch chipset over here that is Marvell 98DX3236. Okay, so and then here are the switch handled by the switch chip. Okay, as you can see. So all of them, as you can see, all of them are handled by a single switch chip. Okay, and then we can set up ingress rate and then egress. Ingress means incoming, egress means outgoing. Okay. Also, we have L3 hardware offloading. Oh yeah. This is also I remember now. Yeah, there is a new feature for layer 3 hardware offload. Okay, so we can say the particular things on that is flowing on a switch is handled by hardware offload, so which is good. So as you can see, hardware offload normally is based on the port, right? So as you can see, when you click, hardware offload is tick. If not, and then it's not enabled. Okay, so when I disabled, see, that's what happened. So this one is off, and because this one is off. Okay, so when I turn it on, click, and then hardware offload is on. So hardware offload again is responsible for transferring data between these ports without affecting the CPU. Okay, but yeah, this is the I think one features from the Mikrotik. Mikrotik is very good at the software engineering. So they can say, oh, okay, so we have a switch chip over here. Oh, for particular layer 3, and then we can do hardware offload. Yeah, we can just take over here. Okay, so yeah, that's the switch feature. So if you want to see switch feature, we can go to switch menu over here. We can see the yeah the naming. We can do mirror, source, and target. So I want to mirror ether 1 or ether 8 to ether 9. Okay, so all traffic from ether 8 will be copied to ether 9, for example. Okay, so this is important if you want to do sniffing. for example, for troubleshooting, or switch all ports, flow control, and so on and so forth. And then so this is the port. Here's the port isolation. Okay. And then so we have here, as I said, so we have a match over here. Okay, so this is a kind of bridge filtering. Okay, but it's done in layer 2. It's done in switch chip. Okay, so as you can see, if you have a bridge, you can do filter over here, right? But again, if you do over here, and then everything will be done in CPU. Okay, but if you do over here, everything will be done in the switch chip. So it can save CPU power over here. Okay, so these are the match, and then here's the action. Okay, copy to CPU and so on and so forth. So we don't have any drop or allow or accept or whatever. So this is like more on like a copy to CPU or for sniffing purpose. Okay, or you want to create a new VLAN ID or VLAN priority for that. Okay, so what do they have? We have MAC address, ports, IP, even IP, right? See. Okay, so we can say that this MAC address belongs to this VLAN, right? We can use this this feature. All right, guys. So I think that's all. Any questions so far? Hello? No questions? Looks like everybody been quiet. I don't know whether it's really understand or not.
No questions, sir.
Say again. Hello. What did you say? You can
No
just type.
question.
No
No
questions.
question.
Okay. Right. Well, if there is no question, and then well, it's time to. Oh yeah, I will share some announcement over here.
I like your explanation.
Oh yeah. Thank you.
Inspiration.
Right.
That's
Thank
good.
you. Great. Thank you. Nice to hear that. Okay. Thanks for still being here up to this time. Not quit. Okay. So I have some announcement over here. So let me share. So hopefully you can understand what I'm saying, right? So where is the button to share? Okay, here it is. Share. Okay. Yeah. Again, we are reaching at end of the webinar. So we are almost 1 hour over here. Yeah. So for those wants to submit a feedback. Okay. So feedback over here, and then you can put the topics over there. You can type. Okay. Okay. Please discuss these topics. Actually, layer 2 is quite big, you know. I'm planning to split the topics into several webinar. Events will be available in our website. Okay. Also, announcement will be there. Slides will be available on Slideshare. Okay. In case you are needed, just type Google GLC networks and then you will find it. Discord. Okay. This is for Bahasa Indonesia. Okay. If you want to join. Okay. Welcome. Recording will be available on YouTube based on the availability of admin. Sorry for that. Okay, so anything else? No? Oh yeah, we have an internship opportunity. So just in case this is for Indonesian only. If you are interested, just go to our website, and then there is a menu called jobs. Okay, on top, and then there is an opportunity for internship. Well, I think that's all. It's time for us for photo session. Please turn on your cameras. Okay. I like it. Okay, thank you. Right, so okay, I will count 1, 2, 3. I forgot the command for a screenshot in Mac, a control or a command shift 4, right? Command shift 4. No? Oh no. Oh, command shift 3. Is it? Oh yeah, yeah, yeah. Okay. Sorry for that. Okay. 1, 2, and 3. Yeah. Oh, okay. Thumbs up, thumbs up. Okay. 1, 2, and 3. Yeah. Good job. Okay, guys, thank you very much for coming. It's really nice to see you guys here. Okay, so I hope you enjoyed the webinar. And then the most important thing is at least you know how the Mikrotik switches looks like. Okay, it's very important because unlike other vendors like TP-Link, Cisco, or others, when you buy, it depends on the switch chip that is embedded in the Mikrotik products. Yeah, either version 1XX or 2XX, they are both the same in terms of configuration, or version 3XX. So,
Hello, sir.
yeah.
Sir, can I have a question?
Hello. Yes. What?
Do you have any training here in the Philippines?
I don't know because yeah, we plan to, but you know, we have coronavirus over here. Perhaps yeah, we have planned to have an online
Uh,
workshop. So this is not a
it's only a webinar or
official a
it's only
workshop like a 1 day workshop. Webinar is just only 1 hour. We cannot talk much in the 1 hour, right? So we think we can create we can set up a paid workshop only 1 day for discussing one topic, either switches or BGP or MPLS or routing and other stuff. Yeah. So perhaps if there is a workshop, and then it's gonna be online workshop. Yeah, in the Philippines, perhaps. Yeah, I was in Philippines in 2016 when there was a Mikrotik user meeting in the Philippines. Yeah, yeah, I was there. Yeah.
so after the training, we will have any certification?
Yeah, but the certificate of attendance, so it's not certificate from the Mikrotik, so because this is just a workshop from us.
Okay.
Yeah, yeah.
Okay.
All right. So, guys, I think that's all. Yeah, it's already night time for everybody, and I think in the Philippines maybe almost 10 o'clock, huh? Yeah.
Yeah.
Your
Yeah.
GMT plus 8
Plus,
or 9?
plus 8.
Oh, plus
Plus
8.
8.
Yeah, yeah, yeah. Yeah, yeah. It must be very late over there. Okay, guys. Thanks again, and then have a nice day. See you in the next webinar. Keep safe, and see you, and goodbye.
Okay, thank you, sir.